So here, now it's continuous from left. So I coming from left, I have to check whether the left limit equal to the function value. So this is the left limit and it's equal to the function value. No? So this one is a yes, this situation. Okay. And next what I have here, f is continuous from right. What can you say for this one? This one, no, no. Why? The left limit, right limit is 2, but the function value is 4. These two are different. See? Okay, these two are different. So for left continuity, no. But right continuity, right limit is equal to the function point. So that is a yes, no? Again, the two-sided, no, because two-sided limit is defined and for, okay, two-sided limit is undefined. No, I have said here undefined. Sorry, I wrote the wrong one there because these two are defined, no? Undefined. But this is 2, okay? Because why these left and right limits are not equal. So because two-sided limit is undefined, here this one is a no. Okay. මෙතන two-sided එක limit එක define නැහැ නේ මේ දෙක වෙනස් හින්දා no. එතකොට මේකේ left continuity එකට yes නේ. මොකද මේ 4 සමානයි මේ 4ට. right continuity එක no. මෙයයි සමාන නැති නිසා. Okay. Now at 6 here again, if I go from this side, I get close to 5. Other side also I get close to 5, no? So the two-side limit is defined as 5, but function value is 2, no? Here. When I get close to 6, exactly at 6, function value is 2, okay? So this is a no, because function value is defined different. This is also no. This is also no. Okay. Any question? Okay. Now let's move to this piecewise functions. This one will copy down. Okay. First, I'll explain what is a piecewise function. Okay. So piecewise functions are like this. Okay. It's defined with pieces. Something like this. Okay, so these functions are is defined from three pieces. So when I want to calculate a function value, for example, let's say I want to calculate one, I have to identify the correct piece. Okay, මේ piecewise functions මෙහෙම වෙනස් කොටස් වලින් define කරලා තියෙන්නේ. එතකොට අපිට මොනවා හරි value එකක් calculate කරන්න ඕන නම් මුලින් මේ මොන කොටසද පාවිච්චි කරන්න කියලා හොයා ගන්න ඕන. Okay, x x f එක x එක calculate කරන්න ඕන නම් මෙතන මම බලනවා මෙතන x දෙකට වඩා අඩුයි නේ. එතකොට එක කියන එක අයිති වෙන්නේ මේ කැලලට. මොකද දෙකට අඩුයිනේ. So x is 1 means it's less than 2, no? So because this part is the less than 1, less than 2. So for f1, I have to use the first part. Okay, so I have 2, 1 minus 3. So I get negative 1. Okay. Then if I want to, okay, 2, I have two pieces connecting at 2, but here I don't have the equal sign, no? So that means f of 2, I have to use this piece. Okay, so function is constant in this piece. So 2, function value is 3, no? Because at 2, I use this piece because I have the equal sign here. F2 එක කරද්දි මෙතන සමාන ලක්ෂණ තියෙන හින්දා අපි මේ කැලල පාවිච්චි කරනවා. F4 also 4 falls behind these two, no? 4 is between 2 and 5. So for that, I use this, okay? Then f of 5, can you tell the function value? What is the function value for f of 5? Good, no? Because I have the equal sign here. Okay, thank you. So here, 6, no? Yeah, okay, that's correct, 6. Okay, then if I do f of 6, I have to use this bigger one. 6 plus 1 is 7, no? Because I'm using this piece for 6. Okay. Any questions? Okay, good. Okay, so we'll go for next one. I'll do this part. Okay. I'll do this part first, okay? Okay, so here I have a given function. First, I have to find all the values of a such that function x going to 2fx is defined. Okay, so here I want to find where the two-sided limit is defined. We know two-sided limit is defined if and only if these two are equal. Okay, so when you are given a function like that, the problem like this, okay, that means a problem where you have to find some value. Okay, find a at all the values of a such that some condition. Normally what you do, you use this condition to build the equation containing this a. Okay, so මේ වගේ ප්‍රශ්න commonly එකක් තමයි මොනවා හරි value එකක් හොයන්න constant එකක මොනවා හරි condition එකක්. ඒ කියන්නේ find a such that. හරි, ඒ જાතිය ප්‍රශ්නවල තියෙන්නේ ගොඩක් වෙලාවට අපි මේ දීලා තියෙන condition එක පාවිච්චි කරලා මේ a තියෙන equation එකක් හදා ගන්න ඕන. Okay, so limit එක define වෙන්න නම් මොකද වෙන්නේ? two sided limit එක define වෙන්න නම් අපි දන්නවා limit x goes to 2, that means right limit have to be equal to the goes to 2 plus fx. No, because left limit and right limit have to be f5 එක නේද? මේ පොඩ්ඩක් කලින් එකේ මේකේ 5 එකක් කෙනෙක් අහලා තියෙනවා. මෙතන f5 එක ගන්නෙ මම මේ මෙතන පහට සමාන නිසා. මෙතන පහට සමාන නෑනේ. මේක සමාන නිසා මෙතන මේ ෆන්ක්ෂන් කැලල් එක තමයි පහේදී පාවිච්චි කරන්නේ. මෙතන සමාන ලකුණ තියෙන හින්දා මේකේ සමාන ලකුණ නැහැ. ඒක පැහැදිලිද? මේ මෙතන පහට මේක ගන්න මේ සමාන ලකුණ තියෙන හින්දා. හරි? මේකේ සමාන ලකුණ නැති හින්දා මෙතන පහට මේ කැලල ගන්නෙ නැහැ. හරි? ඒක පැහැදිලිද? Okay. So here now these two are equal. I can get an equation from equating these two. So I have to find that. Okay. So to find that, I do first I'll find this one. So when x going to 2 to along the values less than 2, no, when I have these two negative sides, if I have x-axis 2 here, I am going to 2 along the negative values, not negative, less than 2 values. Okay, so if I am going to less than 2 x2 along the values less than 2, which part my equation? This one, no, because this is saying less than 2. See, okay, this part is less than 2, so I am going to 2 along values less than 2. I have to use this part. Okay, so limit 2 along this values a squared over 2 times x plus 8. Okay, Now this is a polynomial function. No, we know polynomial functions are continuous, so I can plugging in 2 to get the limit, this limit. Okay, 2 less than 2. I can say 2. Okay, here I can plugging in 2. Why? Because this is a here even I can say 2 because I using left values now. Okay, I even can say I'm going to because I'm going along the values less than 2 when I pick this piece. Okay, so here because this is a continuous function, I can plug in to find the limit. Okay, here denominator 2, no, sorry. Okay, 2. So a I don't know, but x I know. 2 times, sorry, a squared plus 2, no, because x is 2 here. 2 plus 8. So this cancel out. Okay. Do you have any questions about this one? Why I pick this part? Because I am going to do along the values less than 2. Okay. Now I need to find right limit. Okay. So for right limit, I go ඍණ දෙක නෙමෙයි කක් කරන්නේ හේතුව තමයි අපි දෙක ඍණ නෙමෙයි දෙකට අඩුවක් යනකින් යන්නේ දෙකටනේ ඒකයි නේ හරි අපි අර ලිමිට් එකේ දැන් ෆන්ක්ෂන් එකේ y value එක f දෙකට ලං වෙනකොට එක බලන්න මෙතන හිතමු දෙකට උදාහරණයක් ඇටියට මෙතන අපි එකට අඩු මෙතන එකට අඩුවක් යන්නේ x ඍණ එකේ ලිමිට් එක හොයද්දි එක ඍණ කියලා දාන්නේ අපි එකට අඩුවක් යන්නේ කියලා මේ මෙතෙන්දි ගන්නෙ මොකද්ද value එක මේ ෆන්ක්ෂන් පීස් එකේ එකට සමාන එකනේ අපි ගත්ත මෙන්න මේ එකට ලං වෙනකොට ලං වෙන value එක 4 මෙතන මං ලං වෙන්නේ එකට okay so we are getting close to 1 here along the less values less than 1 not negative but less than 1 so I am taking this function piece that's what I am doing now but with the equation no so here I am getting close to 1 along this I use this function piece okay this function piece is when x less than 1 okay so I am taking this function piece okay is that clear ඒක පැහැදිලිද දැන් ඒ කියන්නේ මෙතන මම එකට ලං වෙනකොට මෙන්න මේ piece එක තෝරගන්නවා හැබැයි මම okay good okay it's a good question to ask because it can be confusing little there 2 plus okay that means here I am getting to close to 2 values bigger than 2 okay so bigger than 2 means this function piece no so I can say limit x goes to 2 plus minus 3x okay so here again I plug 2 no so this minus sign is from here a is here and 2 minus 6a now if limit is defined what should happen these two have to be equal no so these two have to be equal I'll write it here now these two is equal negative plus is a squared plus 8 equals to minus 6a. Okay, so know that all, see, we got a equation involving a using this condition. Okay, that is the general strategy to answer these type of question, where find the a such that certain condition is satisfied. Okay, so I keep a here. I can move 6 to this side, no? It will become plus 6a plus 8 equals to 0. Now this is a quadratic equation I can factor. Okay, this one a and a, 4 and 2 gives me the 6, no? 4 and 2 gives me the 6. So here I have a plus. So a plus 4 equals 0, or a plus 2 equals 0. So I get a equals minus 4, or equals minus 2. Okay, so with two values I get for a. Okay, so this is the now it asking to me to find the limit, okay, for each value. Okay, so it was clear. So do you have any questions from this part? Okay, so I'll write this one is here, and I'll go, and a equals -2. Okay, so first part is fine. මේ equation එකක් හදලා අපි ඒක solve කරා. මේක common strategy එකක් මේ જાතිය ප්‍රශ්න වලට answer කරන්න. හරි, find values of a such that කිව්වකින් අපි මේක ඒ තියෙන equation එකක් හදා ගන්නවා දීලා තියෙන condition එක පාවිච්චි කරලා. Okay, now I can find the limit at a. Okay, so when a equals -4, now limit I can use either part because I know these two are equal when x is -4 and x a is 2. Okay, so when x at 4, I know this one 2fx equal limit xa to 2 plus fx and limit fx, no? All of these are equal. Okay, these three are equal, so I can use either one and plugging in a equals 4. So I will plug it for the easier one. Okay, limit x goes to 2 fx I can find the a value for this or this, so it's easier to plug in a for this guy, no, 6a. So I will plug in there, 6a, -4, this is a 24. Okay, so when a is equal to -4, limit of x going to 2, fx is 24. Okay, so here f limit is 24, and when මේක x සමාන මේක ඕන එකකට ප්ලග් කරන්න පුළුවන් මොකද x සමානයි 4 දී 2 දී මේ දෙන්න equal නේ අපි එහෙම වෙන්නනේ හොයාගත්තේ -2 again 2 මේකෙත් අපිට ඕන එකක් පාවිච්චි කරන්න පුළුවන් I'll use this one because it's easier. Okay, f plus, no, actually it's easy. I can use either one. Okay, I know this is equal to both of them again, no? So again, it's easier to use this guy, -6 times -2, I get 12. Okay, any question? Part B, I get 24. So if I write this one, when a is equal to -4, limit of x going to 2fx equals to 24, no? Fx equal to 24, and when limit of x goes to 2, f when a is equal to -2, limit of fx is equal to 12. This is answer for part B, no? Part A, this guy. Okay. So part B. Now part C. So for part C, it's asked to find the value of A such that fx is continuous, no? At 2. So if it is continuous at 2, there are 3 conditions. Fc have to be defined. So Fc is defined what? F2 equal to 12, no? Then the second condition, I have to make sure limit of x to fx have to be defined, no? That is the second condition, is defined. So from this, this one is fine for all a. So up to now, I don't have a restriction of a. For all a, f of 2 is 12, no? Now here I get 2 candidates, okay? And a equals to -2, both of will make this defined. Now I have to use the third condition, limit x of 2 fx equals f of 12. So when I apply the f of 2, no? Okay. So when I apply this condition, what a value I am going to choose? What a value is left? Can you tell? What will be the value to make the function continuous? Yeah, very good, no? it's negative 2. Is that clear? Because f of 2 has to be equal to function value. It's only at 2. Okay. Okay. So the part C. So the final answer for part C negative 2. Okay. මොකද part C එකේදී conditions තුනක් තියෙනවානේ. continuity වලට තිබ්බ condition තුන තමයි so continuity conditions are this f of c defined, f of c, the two-sided limit is defined, f of c fx equal to f of c. So here first f of 2 is 12, no, because here x equals to function value is given to be 12. So that will not put any restriction on a for okay, because it does depend on a x of 2 equal to 12. So the first condition is satisfied here. I don't have to worry about first condition. It's asked me to find when it's continuous. Then I have to make sure second condition of continuity, that is f of c is defined. So here I am at 2. So f of x2 of f2 have to be defined. So from part A, I have two candidates here, no? These two candidates. So both of them make f of 2 defined limit, okay? Limit at f of at 2 it's defined. Okay, so here I have two candidates. Then finally, f of x equals to 2 have to be limit at 2 have to be equal to f of 2. Okay, so that is made for what value? Only for this guy, no? When a equals negative 2, I get 12, but here 24. It's different from f of 2, 12. So here this limit is equal to 12 when only a is negative 2. So for answer for this is x equals negative 2. Is that fine now? Okay, good. Okay. So now we go for part C. Continuous at left. Okay, part D. Find all admissible values of h such that f is continuous from left at 2. Okay. So that means two left limit have to be equal to 12, no? F2. Okay. So this is again I make a equation this time left limit. Okay. So I have the left limit here, a squared minus a squared plus 8 have to be equal to 12. So this is to make it continuous at left, no? So when I get 8 to other side, I get a squared, 12 minus 8, I get a squared 4, no? So then I find the a, I get a plus or minus 2, no? Because square root of 4 is 2. So there are two values to make. Okay, here make it here I want to make sure what f of 2 actually, no, not f of 2, sorry. Okay, so condition for left limit. So the condition for left limit is what? condition for left limit is this guy. Okay, FC is defined, but left limit. Okay, left limit have to be defined, and left limit have to be equal to the f of c. F of c. Left limit means c minus, no? Continuous from left. Okay. So here I look at the function value of 2, no? Because I am calculating the limits at 2. Okay. So my function, so my left limit is this guy, 2 going for from the lesser values for 2, x going for 2 along the less values less than 2. Okay. That is a squared plus 8. So here a squared plus 8 is equal to 12. Because this is the left limit, I make a squared plus 8 equal to 2. That means I'm making left limit equal to 2 to get the left limit. So that is what this is, a squared plus 8 from here equal to 12. Now to solve, I take 8 to other side, I get 4. Then then a is equal to what? Plus or minus square root of 4, no? That is plus or minus 2. Is that clear now? හරි, මේක එතකොට left limit එකට අපි left පැත්ත limit එක මේකට සමාන කරනවා නේ. Okay. Can you do E? Okay, I'll give few minutes if you can find the E and send the answer for E. Okay, good. Okay, let's see. We got 1. Here, what should happen? Limit x goes to 2 plus fx have to be equal to what? F of 2 again, no? So f of 2 is what? 12 here, and this guy I know from here, no? Negative 6a. Okay, how can I solve this one? This one I have to divide both sides by negative 6. Okay, so this cancel out, and a is equal to what? Negative. Okay, I see someone at the 6, but here a 6 is multiplying, no? So I get 2. I think even 18 they mistakenly add the 6 for 12, no? But this situation I have divide, no? Divide by 6, because this, if I had a plus 6, a minus 6, then it's, I take 6 to the other side, sorry, 12, I take 6 to the other side, I get 18. Okay, yeah, that's fine. Okay, good. Okay, so I think it's clear to people now. Now I will do that part. This one takes the continuity as suspicious point. Okay, I'll do this part next time. Okay, it's little bit long. After you try, let me look at the homework problem. I don't think I gave this as a homework. After you finish, try the homework. I'll extend this homework that due date today until next week, Wednesday or something. Yes, okay, I will do the next problem. This one I will do after you try the homework. Okay? Okay. So this continuity theorem, this one says if you have continuous functions, if you multiply that continuous function from another constant is continuous. If you add two continuous functions, result is continuous. If you subtract two continuous functions, result is continuous. If you take the product of two continuous functions, it's continuous. Okay, and if you take the quotient of two continuous functions, it's continuous. And you take the composition of two continuous functions, it's still continuous. Okay, and the composition rule says if you have a composition function, this composite function means if you have two functions, okay, let's say fx equals to x squared and gx equals to x plus 5. Okay, then f composition dx means I'm plugging in dx for f. Okay, so here f plugging in dx. Okay, so that means this composition is this one. I can plug in x plus 5. Okay, So x plus 5 squared. Okay, that is if I FOIL, I get x squared plus 5x from this x squared 5x from this 5x and 25. No, so 10x plus 25. Okay, so I said f of gx, that means I plugging in gx for f. Okay, other way, if I say g of fx, I am plugging in g here and fx. Okay, so g of fx, so here g of x squared, no? I'm plugging in x squared for g. So in the place of g, I have x. If instead of x, I am plugging in x squared, no? So this is g of f. Okay. Okay, PDF is in the let's see, it's in the under lecture notes. Okay, so let me check. If you go to this, sorry, my sources. No, this one, your course, Math LMS, homework, this lecture note part have this PDF. Okay, see this piecewise function is this part and this guy. Okay, so it's on LMS. Okay, if you don't have the access for LMS, let me know. I can send it in the chat. Okay, so this is a composite function, and this okay. Okay, composition means I am plugging in the function for one function for another function. Okay, so here I have fx, here I have gx. Okay, so if I say this f of gx, what I am doing, I am plugging in gx for x. Okay, it's like this actually. Function I can take as a machine, no? So here, when I have two machines, like first function is like I have f of x equals x squared. So this one, what happens if I put 3, I get 9, no? 3 squared. If I put 2, I get out 4, like that. Okay. So if I put x squared, sorry, if I put in general x, this function output a x squared. Okay. Then second function is this function g. Okay. If I put x, its output x plus 5. So when I composite, what I do, I connect two functions. So if I say f of g, okay, what I do, I have this g first. I input the output of g to x. So here I have this x plus 5 and I connect these two functions maybe like this and put it to f. So this x plus 5 going to what? F and give out a x plus 5 squared. Okay, that is what I do in this part. Okay, මේකෙදි කරන්නේ මේ functions දෙකක් තියෙනවා නම් ඒ දෙක connect කරනවා මෙහෙම. එකක output එක අනිත් එකේ input එකට දානවා. හරි, එතකොට g of f කිව්වොත් මෙතන මම කරන්නේ මුලින් g එක අරගෙන ඒකෙන් එන output එක කෙලින්ම f වලට input කරනවා. එතකොට x plus 5 square එකක් output කරනවා. This is like if you have two machines. Okay, one, if you put a fruit into that, it gives you a peeled fruit. Okay, it peels the fruit. And next one, if I put a peeled fruit, it gives juice. So if you connect these two functions, when you put a fruit, it will give juice. It will peel first and then produce the juice. Okay, මෙතන නිකන් හිතන්න පුළුවන් machines දෙකක් තියෙනවා. එක machine එකකට පළතුරක් දැම්මොත් ඒක ලෙල්ල අරලා දෙනවා. අනිත් machine එකෙන් ලෙල්ල අරපු පළතුරක් දැම්මොත් juice දෙනවා. එතකොට ඔය දෙක connect කරවොත් මෙහෙම කෙලින්ම පළතුරු දැම්ම ගමන් මුල් එකෙන් ලෙල්ල අරිනවා ඊළඟ එක ඇතුළට ගිහිල්ලා juice එක එනවා. ඒකත් කරන්නේ එහෙම මේ input එකක output එක අනිත් එකේ input එකට feed කරනවා. ඒක හොයාගන්න පුළුවන්. එතකොට මේ ළඟින් තියෙන එක input කරනවා. x plus 5 නේ. එතකොට output එක x plus 5 squared. Okay. ඒක පැහැදිලිද දැන්? Okay. Good. Okay. Now here I connected this way, other way I connect other way. So I'm inputting f into g, no? So if this one is going here g of fx, I am inputting fx to g, other order. Okay. So g, here I am inputting x squared for g. So this is x, no? So in the place of x, now I have to write x squared plus 5. Here I am taking f first. So I put x, I get out x squared. Then this one, x plus 5 function, so I get x squared plus 5. Okay. Okay. I think someone's mic is on. Okay, someone's mic is on. Can they mute it? Okay, thanks. Okay. So now let's go. I will leave this last part also. That one there is a question, but I'll do it next time after you try the homework. Okay. I will extend the homework until next Wednesday. There is one part we have to do. I will do that after you try the homework problems. Okay, I will move on to the next section. Okay, about these limits. Okay, let me see the drive. Okay, let me check whether we have, because I removed some part from calculus. Okay, this infinite limit also I will talk about next time after you try the homework. Okay, until now, this is not that difficult, but I'll go that over that after you try the homework. Okay, uh, so I will parallelly start the differentiation. It don't have to go uh, now we know enough about limit to talk about the differentiation. So I will start uh, differentiation today. I will introduce the definition. Okay, uh, I think it is be better to do that way. Okay, because this infinite limits, we can talk about the differentiation without the infinite limits. Okay, so I'll discuss about infinite limits uh, next class. Okay, for now we'll do this differentiation on this one, because some people are using them in courses. Okay, so differentiation and integration, then let's see whether we discuss the infinite limits or not. Okay, okay, differentiation, I'll play a video first. It explains all of this note. Okay, it's good, try to follow it. It's good if you can follow it. Okay, but you need to learn is what is it, when the definition is given, you have to know to differentiate. Okay, give me a minute. I'll
The derivative. Defining the derivative. This video is the first video of a series of videos about derivatives. In this video, we will construct a formal definition. Now that we have both a conceptual understanding of a limit and the practical ability to compute limits, we have established the foundation for our study of calculus, the branch of mathematics in which we compute derivatives and integrals. Most mathematicians and historians agree that calculus was developed independently by the Englishman, Isaac Newton, and the German, Gottfried Leibniz. When we credit Newton and Leibniz with developing calculus, we are referring to the fact that Newton and Leibniz were the first to understand the relationship between the derivative and the integral. The derivative extends the concept of the slope of a straight line to other functions. Let's begin our discussion by revisiting the slope. A straight line or line is an endless one-dimensional figure that has no width. It can be thought of as a connected set of infinitely many points. A straight line does not have any curve in it. The figure on the right is of a straight line, but the one on the left is not of a straight line. The one on the left contains curves. The word slope, gradient, incline, pitch, is used to describe the measurement of the steepness of a straight line. The slope of any line remains constant along the line. The higher the slope, the steeper the line. The blue line has a slope of 2, the green line has a slope of 6, and the purple line has a slope of 20. Observe that the green line has a higher slope than the blue line, and it's steeper than the blue line. The purple line is the steepest and it has the highest slope. Slope m, of the straight line passing through the points P with coordinates x1, y1, and q with coordinates x2, y2, is obtained by dividing the difference of y coordinates by the difference of x coordinates as shown in the formula. Slope can be calculated by using the coordinates of any 2 points on a line. The concept of the slope, the rate of change of straight line, could give important information. The slope of a mountain measures the steepness of the mountain. Also, for instance, the slope of a line could represent change in height over time, velocity, speed, or acceleration. In this instance, according to the graph, the object has traveled 20 meters in 5 seconds, so the speed is 4 meters per second. As you see in this case, the slope gives the speed. Except for rare examples, most of the time graphs we find in applications are not straight lines, but still, we would like to know the rate of change for those graphs. Unfortunately for curved graphs, the rate of change varies from point to point. The slope formula for straight lines does not work in these situations. Example 2. The position of a car is given by ft equals t squared. Can we find the speed of the car after 1 second of motion? Let's try the slope formula. If t is equal to 1, then f1 is equal to 1. Therefore the point, 1, 1, is on the graph. We need another point. If t is equal to 2, then f2 is equal to 4. Therefore the point, 2, 4, is on the graph. Let's label the point, x1 y1 equals 1, 1, x2 y2 equals 2, 4. Applying the slope formula. The slope m is equal to the difference of y coordinates y2 minus y1, divided by the difference of x coordinates x2 minus x1. Let's plug in the values. Y2 is 4, y1 is 1, x2 is 2, and x1 is 1. By simplifying we get a slope of 3. Observe that if 3 equals 3, then f3 is equal to 9. Therefore, 3, 9, is on the graph. If we pick x1, y1, equals 1, 1, and x2, y2 equals 3, 9, and apply the slope formula, we get a slope of 4. Here we get 2 candidates for slope at t equals 1, but the car should have only 1 speed at t equals 1. How do we know the correct one? Actually, neither is correct. Straight lines have a constant slope, but this is not true in general. The slope formula of a straight line does not work for ft equals t squared. We cannot speak of the slope of t squared because it varies from point to point. In the face of nonlinear functions, the slope formula of a straight line fails. Mathematicians introduce a new concept, derivative. The derivative of a function, f at a point p, gives the rate of change of the function, f at p. It extends the concept of the slope beyond the straight lines. Before going into the discussion of the derivative, let's list 2 crucial concepts. A secant line is a straight line joining 2 points on a function. The figure below shows the secant line connecting point 1, 5.6, and point 3, 2.4. The tangent line, or simply the tangent, to a curve, at a given point is the straight line that just touches the curve at that point. The figure below shows the tangent line through the point 1, 5.6. As you can see, the line just touches the point 1, 5.6. There can be infinite secants drawn through a given point, but there can be only one tangent line through a given point. The problem we faced, when we tried to find the speed at t equals 1, can be explained using secant lines and tangent lines. Observe that applying the slope formula to points 1, 1 and 2, 4, we get the slope of the secant line, joining the points 1, 1 and 2, 4, which gives the average speed of the car in the time interval 1, 2. Applying the slope formula to points 1, 1 and 3, 9, we get the slope of the secant line joining the points 1, 1 and 3, 9, which gives the average speed of the car in the time interval 1, 3. We want to find the exact speed of the vehicle at t equals 1, the value of the speedometer at t equals 1. The slope of the tangent line to the graph at t equals 1 gives the exact speed at 1. We only know one point on the tangent line. The slope formula requires 2 points. Derivative goes around this problem by expressing the slope of the tangent line as a limit of slopes of secant lines. Let's look at the definition of the derivative. For the demonstration, we use a graph of a parabola, but the definition we construct works for any function.
Suppose we have to find the slope of the tangent line to the graph of the function fx at the point with x-coordinate x. Then the y-coordinate of this point is given by fx. We get it by plugging in the x-coordinate x into function f. We have to find the slope of the green tangent line, passing through the point with coordinates x, f, x. Let's label the slope of the tangent line by mt. We only know one point on the tangent line. We can't directly find the slope of the tangent line. Let's move to point h units to right on the x-axis. The point above this on the graph has x-coordinate x plus h and y-coordinate f x plus h. We get the y-coordinate by plugging in x-coordinate x plus h into function f. Consider the red secant line passing through points with coordinates x, fx, and x plus h, f, x plus h. Let's label its slope by mh. The slope m of the line passing through points x1, y1 and x2, y2 is given by the formula 1. Choosing x1, y1 to be x, fx, and x2, y2 to be x plus h, f, x plus h, and applying the slope formula given by 1 to red secant line, we get 2. Where mh is the slope of the secant line. Simplifying 2 by cancelling out x in the denominator, we get 3. As h approaches 0, the red secant line approaches the green tangent line. Therefore, as h approaches 0, the slope of the red secant line approaches the slope of the green tangent line. This could be expressed by the limit statement for. In 4, replacing mh by 3, we get 5. For a given function f at a point x, if the limit given by 5 is defined, we call it the derivative of f at x. The derivative gives the rate of change of x at point x. Also, the derivative gives the slope of the tangent line to the graph of f at point x.
The slope formula failed for nonlinear functions. The derivative extends the concept of slope to nonlinear functions. The definition of derivative expresses the slope of the tangent line as the limit of slopes of secant lines. This elegant idea is extremely important. Most of the functions we encounter in practical problems are differentiable. In the next videos, we would further explore the definition. We would show how to apply this definition to solve practical problems, including the problem of analyzing the motion of an object whose position is given by a nonlinear function.
Okay. I'll explain it in Sinhalese. Were you able to see the video? Okay, thank you. So what happens here is we want to find the slope of a tangent line, okay, or the rate of change of x squared or something. So I will summarize, explain a summary. Okay, so we want to find we have a function okay, like this x squared. Let's see. Okay, I think we'll get the okay. So we want to find the tangent of this green line L, slope of this green line L. හරි මේ නිල් පාටින් green පාටින් දීලා තියෙන tangent line එකේ slope එක හොයාගන්න ඕන අපිට. ඒකේ slope එක හොයන්න නම් point දෙකක කණ්ඩාංක දැනගන්න ඕනනේ. We have to know 2 points of coordinate. But this one I only know this one. X naught, this fx naught. Okay. So what we do, we draw a secant line, we go h units here. Okay, let me make it bigger. Okay, so I go, this is the where I want to find the slope of this green line. Okay, so if this is x naught, if my function is f, I plugging in x naught to the function, no, to get the y coordinate. So this point coordinates are x naught, fx naught. මෙතන මං x naught වලදී function එකේ coordinate එක x naught, fx naught. හරි? මේකෙන් අහන්නේ මොන වගේ ප්‍රශ්නද කියලා මං කියන්නම්. Okay, so here if we go h units this way, here this one have x naught plus h. Coordinate here x naught plus h. Okay, මෙතන x naught plus h තමයි මෙතන coordinate එක. එතකොට මට මේ line එකේ slope එක හොයන්න පුළුවන්. slope formula එක එන්නේ by slope එක එන්නේ m. මේකට අපි secant line එකක් කියලා කියනවා මෙහෙම යන එකට. and draw this y2 minus y1 over x2 minus x1 නේ. y කණ්ඩාංකවල වෙනස x කණ්ඩාංකවල වෙනසෙන් අනුක්‍රමණය නේ. මෙන්න මේ කළු line එකේ අනුක්‍රමණය කියන්නේ මේක. මේකට මට plug කරන්න පුළුවන්. I can plugging in here f, here y කණ්ඩාංක x naught plus h, minus f x naught no y කණ්ඩාංකවල වෙනස මේ mx කියන එකේ මේ කළු ලයින් එකේ ස්ලෝප් එක තමයි mx වලින් දෙන්නේ නේ අනුක්‍රමණය එයා එන්නේ x naught plus h minus x naught බෙදන්න ඕන x කණ්ඩාංකවල වෙනසින් ඒක එන්නේ x naught plus h minus x naught නේ මෙතන x naught plus h minus x naught මෙතන fx naught plus h minus fx naught හරි එතකොට මෙයා මෙන්න මෙතන මට x naught එක කැන්සල් කරන්න පුළුවන් එතකොට මෙතන උඩ එනවා තියෙන්නේ fx naught plus h මයි ඕක තමයි mx කියන්නේ මෙන්න මේ කළු ලයින් එකේ ස්ලෝප් එක mx okay but if we send this h to 0 limit of h to 0 this black line overlaps this purple line okay so if I want the slope of this tangent line this l is the tangent okay if I want the slope of this tangent line I can take the limit h goes to 0 okay fx naught plus h minus fx okay I cannot find the slope of the tangent line purple line using the slope formula මට මේ tangent line එකේ slope අනුක්‍රමණය හොයාගන්න බෑ මොකද ඒක උඩ තව ලක්ෂයක් මම දන්නේ නැහැ ලක්ෂ දෙකක් දන්නේ නැහනේ ඒක හින්දා මම මේ secant line එකක් අඳිනවා ඒක අරහා යන ඒකේ අනුක්‍රමණය හොයන්න පුළුවන් slope formula එකෙන් මොකද ඒකට ලක්ෂ දෙකක් තියෙනවා මේ මෙතනනේ ලක්ෂ දෙකක් තියෙනවා එතකොට ඒක එක මට මේ slope formula එක හොයාගන්න පුළුවන් හරි ඊට පස්සේ මෙන්න මේක ස්ලෝප් එක හොයාගන්න පුළුවන් ඒක තමයි මේකෙන් දෙන්නේ. එතකොට මම ඒක h එක 0ට යවුවොත් මෙන්න මේ කළු ලයින්ස් ටික ගිහිල්ලා පර්පල් ලයින් එකේ ඕවර්ලැප් වෙනවා. එතකොට පර්පල් ලයින් එකේ ස්ලෝප් එක තමයි මේ කළු ලයින්ස් වල ස්ලෝප් එක ලිමිට් එක h බිඳුවේදී. හරි? ඒක පැහැදිලිද? ඕකේ. දැන් මේක පැහැදිලිද? තව විස්තර කරන්න ඕනද? මේක විස්තර කරන්න ඕන කියලා කියනවා කට්ටිය ඒක පැහැදිලිද දැන් මෙතන මෙන්න මේ h එක බිඳුවට යනවා හරි එතකොට මේකෙත් එන්නේ y කණ්ඩාංක වලස බෙදීම x කණ්ඩාංක වල වෙනස okay I'll explain it again okay I'll go this time so what happens here මේක මට මෙන්න මේ derivative එක කියලා කියන්නේ function එකක මෙන්න මේ tangent line එකේ slope එක. නැත්නම් මේ tangent line එකේ මම මුලටම යන්නම් පොඩ්ඩක්. වෙනස් වීමේ මෙන්න මේ tangent line එකේ slope එක තමයි යෝනා. හරි මේ tangent line එකේ slope එකෙන් තමයි function එක වෙනස් වීමේ ශීඝ්‍රතාවය දෙන්නේ. එතකොට අපිට මේ tangent line එකේ අනුක්‍රමණය ඕන. හරි? සාමාන්‍යයෙන් අපි straight line එකක අනුක්‍රමණය හොයනවා නම් අපිට slope formula එක පාවිච්චි කරන්න පුළුවන් නේ. මෙතන okay I will show you okay after this one මේ part එක මම upload කරලා නැහැ මම ඒක upload කරන්නම් බලමු හරි අර limits part එක තියෙනවා දැන් මම මේ part එකත් upload කරන්න okay so මෙන්න මෙහෙම තියෙනවා නම් අනුක්‍රමණීය රේඛාවක x එක y එක x2 y2 okay අනුක්‍රමණය හොයන්නේ අපි y කණ්ඩාංක වල වෙනස බෙදීම x කණ්ඩාංක වල වෙනසනේ okay දැන් මෙතන වැඩේ තියෙන්නේ මට මෙන්න මේ purple line එක තමයි tangent line එක. ඒකේ slope එක තමයි මට ඕන අනුක්‍රමණය. ඒකේ උඩ මේක ස්පර්ශ වෙන්නේ එක ලක්ෂයකදීනේ. හරි? එතකොට ඒකේ දාන්නේ මම එක point එකක ඛණ්ඩාංක විතරයි. මේ graph එකේ fs graph එක. එතකොට මට ඒකේ ඛණ්ඩාංක හොයාගන්න පුළුවන් මේ x0 වලදී fx කියන්නේ x0 නම් y කියන්නේ මේ x0 එක ෆන්ක්ෂන් එකට ප්ලග් කරාම එන්නනේ. එතකොට මේකේ ඛණ්ඩාංක මෙතන ඉන්නේ x0 fx0. okay. මෙතන ඉන්නේ x0 fx0 කියලා. හැබැයි අපිට ඒ පොයින්ට් එක විතරයි තියෙන්නේ ටැන්ජන්ට් ලයින් එක. එතකොට අපිට මේ අනුක්‍රමණයක දාන්න බෑ ටැන්ජන්ට් එකට. හරි? ඒක නිසා මම කරන්නේ මෙන්න මේක මේ ලයින් එක මේ එකක් අඳිනවා මෙතනින් h ට ගිහිල්ලා මෙන්න මේ දුර h. හරි? මේ දුර h නම් මෙතන ඛණ්ඩාංක x0 නම් මෙතන x0 ඛණ්ඩාංකෙන්නේ x0 plus h නේ. මේකෙන්නේ x0 plus h. හරි? එතකොට මෙන්න මේ ලයින් එකේ LH කියලා ගත්තොත් LH එකේ ස්ලෝප් එක මට හොයාගන්න අනුක්‍රමණය හොයන්න පුළුවන්. මොකද ලක්ෂ දෙකක් තියෙනවානේ. හරි? so මට මේකේ අනුක්‍රමණය හොයන්න පුළුවන් MH කියලා ගමු ඒක අපි. ඒකේ අනුක්‍රමණය y2 y1 x2 x1 නේද? හරි එතකොට මේක තමයි මම x1 y1 කියලා ගන්නවා. හරි? මේක ගන්නවා x2 y2 කියලා. දැන් points දෙකක් තියෙනවානේ. එතකොට මට MH එක හොයන්න පුළුවන් y වල වෙනසෙන්. okay? y වල වෙනස කියන්නේ fx0 plus fx. ඒ කියන්නේ y දෙක sorry මේක x එක y එක නේ. හරි. okay? මේ කියන්නේ x දෙක y දෙක. එතකොට y දෙක කියන්නේ මෙයා. මෙතන y එක කියන්නේ fx0. okay? ඊළඟට යට එකේ එන්නේ x0 plus h එක අඩු කිරීම x0 නේ. මෙතන y දෙක minus y එක x දෙක minus x දෙක. ඒ කියන්නේ මෙයාගේ වෙනස. හරි? මෙන්න මේ ඛණ්ඩාංක දෙකේ වෙනස. මේ දෙකේ වෙනස තමයි මේ අනුක්‍රමණය දෙන්නේ. එතකොට මෙතන මේ x0 කැපිලා යනවා නේ. එතකොට අනුක්‍රමණය එන්නේ මේකේ f x0 plus h minus fx0. හරි? ඊට පස්සේ මට කරන්න තියෙන්නේ මට දැන් මෙන්න මේ කළු රේඛාවේ ලිමිට් එක හොයාගන්න පුළුවන්. ඊට පස්සේ වෙන්නේ මොකද්ද? මම h බිඳුවට යවනකොට මම h එක බිඳුවට යවනකොට මෙන්න මේක මේ පැත්තට යනවා මේ රේඛාවනේ. එතකොට වෙන්නේ මොකද්ද? මෙන්න මේ අර වීඩියෝ එකේ දැක්වා වගේ මෙන්න මේ රේඛාව ගිහිල්ලා මේ කන්වර්ජ් වෙනවා. එහෙම නැත්නම් සමපාත වෙනවා මෙන්න මේ පර්පල් ලයින් එක එක්ක. එතකොට පර්පල් ලයින් එකේ ස්ලෝප් එක වෙන්නේ මෙන්න මේවා බිඳුවට යවුවම එන ස්ලෝප් එක. limit h goes to 0 මේ පර්පල් එක ටැන්ජන්ට් එක කිව්වා නම් ඒ ටැන්ජන්ට් එකේ ස්ලෝප් එක ගන්න පුළුවන් h ටික බිඳුවට යවලා මේකේ. මේකේ මම උදාහරණයක් කරලා පෙන්නන්නම්. මේක බිඳුවට යනකොට. ඒක දැන් පැහැදිලිද? පැහැදිලි නැත්නම් කියන්න මම ඊළඟ පාර චුට්ටක් ආයෙ හිතලා ආයෙ විස්තර කරන්න පුළුවන්. මේක ආයෙ විස්තර කරන්න ඕනද දැන් පැහැදිලිද? එතකොට මේ purple line එකේ අනුක්‍රමණය කියන්නේ h බිඳුවට යනකොට මෙන්න මේ කළු රේඛාවල් වල අනුක්‍රමණය. හරි? මේ වීඩියෝ එකට මම link එක දාන්නම්. මේක පැහැදිලිද දැන්? Okay, good. Okay. So, okay, very good. Okay. So now we can use this to this definition to find derivatives. Okay. So let's say you want to find the derivative of x equals x squared. Okay. Find the slope of the tangent line or the derivative at fx equals x squared. Okay. So m tangent, what I do, I will use this definition. I say limit h goes to 0, fx plus h minus fx over h. Okay. So here limit 0. So this is the definition we construct. No. So here I do x plus h squared minus x squared. Okay. Here I am plugging in x plus h for x squared. Ne metan x plus h x squared වලට plug කරනවා. Okay. එතකොට මෙතන x squared දෙනවා. Okay. Then I can expand this. X plus h squared, I can expand it square. Okay. One. Okay, sorry, I didn't write this one. I can foil it, no? So here, okay. Oh no, this one, no, I need to delete this one. No, erase this one. So recall that if I have 2 to the squared, it means 2 times 2, no? So this x plus h squared means x plus h times x plus h. Okay. Minus x squared. So here I can FOIL this. Okay. X squared plus x times x is x squared, no? X times x is xx, hx. Okay. Plus here I go by again h. This is hx, h squared. Okay. Then h times x is this. Okay. Minus I have x square here. Okay. Then everything I divide by h. Okay. Now here I get 2hx plus h squared over h. Okay. So here I expand this. මෙතන මම ඒක expand කරා. ඊට පස්සේ මේ x squared කැපුණා මේක එනවා. තාම මට limit එක ගන්න බෑ මේ common එක පිටට අරන් අපි අර කරා වගේ cancel කර ගන්න ඕනනේ. මෙතන limit x goes to 0. Here common factor x is here, no? So I pull out this x. I get 2x plus x over x. Okay, so I cancel out this limit. So I get limit x going to 0, 2x plus x. Okay, when I send x to 0, I get 2x. See, so this is the derivative of x squared, no? X squared 2x. So this is taking the derivative using the definition. මෙහෙම තමයි derivative එක definition එකෙන් හොයන්නේ. හැබැයි මේක අමාරු හින්දා අපි අර formulas හදනවා මේ definition එක පාවිච්චි කරලා. Okay? අපි formula හදාගත්තට පස්සේ ඒක ලේසියෙන් differentiate කරන්න පුළුවන් ගොඩක් මීට වඩා. හැබැයි මම formulas හදන ඒවා දෙක තුනක් පෙන්නන්නම්. ඊට පස්සේ අපි ඒ formulas පාවිච්චි කරලා ලේසියෙන් differentiate කරන්න පුළුවන්. Okay? So this is called the derivative or the slope of the tangent line of x squared. So if you have taken A-level maths, you have seen this. If not, don't worry. Okay, there is a easier method of this is how. Okay, this is how we construct the derivative using the definition. After that, we use this as formulas. You will learn how to do it using formulas. Okay. This is just for your knowledge. You will get a simple question like this in the exam, but not more than this. We will learn easier way to differentiate using the formula. This is how we construct the formula. Okay, so you have to see that at least, and maybe if you understand this, it's good. But I will tell you, it will become easier after we construct one or two formulas using the definition. We will directly jump into the formulas and we will start to use formulas. Okay, මේ derivative formulas හදන්නේ මෙහෙමයි. මේ ඕගොල්ලන්ට මේක පෙන්නුවට විභාගෙට ඕනම් පොඩි කැලලක් එයි. ඊට වඩා මේ ගොඩක් අහන්නේ නැහැ. හැබැයි ඕගොල්ලන්ට තේරෙන්න ඕන මේ formulas ගන්න මෙහෙම කියලා. හරි, ඊට පස්සේ formulas ගත්තට පස්සේ අපි differentiate කරන හැටි formula පාවිච්චි කරලා කරන්න පුළුවන්. ඒක ගොඩක් ලේසි. හරි, ඔයගොල්ලෝ A level maths කරලා තියෙනවා නම් දන්නවා x squared වල derivative එක 2x කියලා formulas වලින්. මේකේ පෙන්වන්නේ මේ derivative එක ගන්න හැටි, formulas කීපයක් හදන හැටි. Okay, ඊට පස්සේ formulas පාවිච්චි කරලා differentiate කරන හැටි කියලා දෙන්නම්. හරි? මොනා හරි මේකේ ප්‍රශ්නයක් තියෙනවද? Do you have any questions about this? How many of you understood this? තේරුණාද මේක? මේක තේරුණාද නැද්ද කියලා කියන්න ඉවර වුණාම ක්ලාස් එක මේ ඩෙෆිනිෂන් එක මොකද මේ නිකම් මට මේ කියන්නේ මේක මේ නෝට් එක මම දාන්නම්. හරි, මේ නෝට් එකේ මෙතනට එනකන් ලිමිට්ස් වලට වෙනකන් දාලා තියෙන්නේ ඩෙරිවේටිව් ටික මම අද අප්ඩේට් කරන්නම්. ඕකේ, එක්කෙනෙක් අහුවා මේ නෝට් එක ගන්න හැටි. මම අර වීඩියෝ එකේ ලින්ක් එකයි මේකයි අප්ලෝඩ් කරන්නම්. I will upload. Okay, good. Okay, here you I don't know how you might go to this one. Okay, home. If you are registered for the class, you can go for mathematics here. If it's don't come in this panel, go to mathematics and you can go to courses. Okay, this your LMS page will be different. This is mine. math courses. So if you get into course, to me it's come along this tab. Okay, it will depend on your LMS. After you get to this page, here you have this lecture notes. Okay, in this one I have this. Okay, I think differentiation part is also there. Okay, so it's under lecture notes. Let me know if you don't know how to get to this course. We'll can try to find out. Last time some people said how to go there. මේක ගන්න හැටි තේරෙන්නේ නැත්නම් ආයි අහන්න. මේ LMS එකේ මේ ඕගොල්ලෝගේ math course එකට යන්න ඕන. ඒකට ගියාම මේකේ lecture notes යටතේ මේ note එක තියෙනවා. හරි? ඒ හැබැයි එක එක්කෙනාගේ LMS එක ඒකට යන හැටි ටිකක් වෙනස් math course එකට. මම හිතන්නේ මේ math under math courses your LMS says if you go to mathematics and this is for me. Okay, this is the timetable. Yes, so okay, it will depend on little bit on the LMS course. Okay, so if you don't know to go to LMS, let me know. I'll try to find out how. Last time people explained how to go to the LMS. Okay, so then do you have any questions from the worksheet or any other questions? So I will upload the link for that video. It's not in LMS. I will upload that video link for LMS. And so next time this lecture video to LMS today. Okay, so watch this lecture and try the homework. I will extend it until next Friday. Okay, because there is one section I have to do from the homework. Before going into derivative, I want you to try that homework and then watch this lecture. Okay, so next time I will show you how to use that definition. So how to use formulas and differentiate. Okay, then we'll get back to that limit remaining part later, because some people need this differentiation and integration in their courses. Okay, මේ සමහර අයට integration and differentiate ඕන නිසා මම මේ differentiate කරන හැටි integrate කරන හැටි කියලා දෙන්නම්. ඊළඟට මේ limit function එක අපි හැමීට ඉවර කරමු. මේ worksheet වලින් මොනවා හරි ප්‍රශ්න තියෙනවද ඔයගොල්ලන්ට? Oh, okay. Worksheet වලින් ප්‍රශ්න නැත්නම් ඔයගොල්ලන්ට log out වෙන්න පුළුවන්. Okay, you can log out if you don't have any questions. I will stop the lecture in 5 minutes. Okay. Yeah, you can log out if you don't have any questions. Okay. Questions මොකුත් නැත්නම් log out වෙන්න නැත්නම් ඔයගොල්ලන්ට අහන්න පුළුවන්. මේ lecture notes එක LMS එකේ තියෙන්නේ. හරි? Under lecture notes tab. If you don't know how to go to the course, let me know. I'll try to see. It may depend on your LMS page. Okay, welcome. Okay. Okay. ඔයගොල්ලෝ log out වෙන්න ප්‍රශ්න නැත්නම් Welcome. Okay. Welcome. Okay. Yeah. This recording of the lecture is under these lectures. Okay. See, if you look at here, lecture 2, lecture 3, lecture 1 recording got lost because of a power failure, but from lecture 2, I have these recordings. Okay. It's under these lectures. If you go to this link, it's on YouTube link. Okay. Because otherwise, I have to break it down into pieces. Okay. මේ lecture videos තියෙනවා. මෙතන lectures කියන section එක යටතේ. හරි LMS එකේ මම ඒක මේ YouTube link එකක් දාලා තියෙන්නේ මොකද නැත්තම් මේකේ කෑලි කපලා දාන්න වෙන්නේ. ඉඩ නැහැ. ඔක්කොම එක දාන්න. So if you click on this link, it goes for the lecture. Okay, welcome. Okay. Okay, I'll end the meeting now. Okay, it seems no question.